Hello and welcome to another edition of Brain Maths. In this video, we want to look at the determinants of a 2 by 2 matrix. The way we find the determinants of 2 by 2 is different from how we do it or solve it when it comes to 3 by 3. But what we'll be doing in 2 by 2 would help us greatly when we get to 3 by 3. So we have to pay attention to what we'll be doing here. For 2 by 2 matrix, if a matrix A is given with elements A11, A12, A21, and A22. A determinant or the determinants of A, which is written as this, or that A is found by drawing a diagonal in the matrix that is given, that is the leading diagonal minus the other diagonal. So what we'll be having here is going to be these two, A11 times A22 minus A12 times A21. So whatever we get in these two will be our final answer. So the answer for this place minus the answer for the other one. So looking at what we are given here, we have matrix M and matrix N. So if we are to solve for the questions on the board, we have the determinants of N, M, N, the determinants of M plus the determinants of N, and then the transpose of M and its determinants. So for us to do this, let's start from the first one. A, we have the determinant of M. So our matrix M, its determinants will be 4, 3, 9, 6. As I said earlier, you draw a diagonal, and then considering the leading diagonal. The leading diagonal in this case is 4 and 6. So we say 4 times 6 minus the other diagonal, which is 9 times 3. And our 4 times 6 is 24 minus 9 times 3, which is 27. And that is going to give us minus 3. Now, if we take the second one, which is matrix N, B, the determinant of matrix N, which is minus 8, 4, 3, and 6. Using our diagonals, so we have minus 8 times 6 minus 3 times 4. Minus 8 times 6 is going to give us minus 48 minus 3 times 4, 12, which is minus 60. So the third question says we should find the determinants of M and then add the answer to the answer for the determinants of N. So if we go back to what we have done in question A and B, we've already found the answer to the determinants of M, and we have gotten that of the determinants of N. So let's try to add them together and see what we are going to get. So this one says minus 3 for the determinants of M plus minus 60 for the determinants of N. Minus 60, excuse me, minus 60 for the determinants of N. So we have minus 3 plus times minus minus 60. And this is going to give us minus 63. So that is that for the determinants of M and N added together. Now the fourth question says we should find the determinants of M transpose. So in this case, before you get the determinants of M transpose, we first need to transpose this M. So our real question is M transpose determinant. But before we arrive at M transpose, we first need to transpose ordinary M without its determinants. So our M now is 4, 3, 9, 6. If you don't forget from what we have done in our previous lessons from M, our M transpose will be the interchanging of the rows for column or the interchanging of the column for row. So whichever one you take, you are going to have the same answer. So let's interchange rows for column, the column rather for rows. So if we are taking column for rows, we have 4, 9, and then taking the second one, we have 3, 6. Now we have transposed our M. The next thing is to find the determinants of this M transpose. So we have M transpose determinant. So following the rule of determinants of 2 by 2, we look for our diagonals and then subtract the answer of their products. So the first diagonal, which is the leading diagonal, gives 4 times 6 minus the second diagonal gives 3 times 9. 4 times 6 is 24 minus 3 times 9, which is what? 27. 24 minus 27 is going to give us minus 3. So the transpose and the determinants of M gives another minus 3. I'm going to be leaving you with this question on the board. We have matrix R with 2 by 2 and another matrix S with another 2 by 2. So you are expected to find the determinants of R, determinants of S, and at the same time find the determinants of R transpose. So if you are just joining us on this beautiful channel, I think it's high time you subscribe to this channel. Help us to like the video and as well share to as many people as possible. Until I come your way again next time, do have a wonderful day.